Okay, so let's just walk through this example, or the solution for this example rather, together, just to see if this is more helpful for you. So we set up our initial matrix A, and that matrix is going to come from the specific details that are given in the problem here. So we have some information about what percent of Republicans and Democrats return or go to the other party. And from that, we can create our matrix A. That's pretty important when you're setting up the matrix to make sure that the individual groups, in this case Republicans or Democrats, are set up in their values in a column like this. Sometimes the information that's given requires you to switch the orientation, so it may look like they're going in horizontal, but really they're categorized vertically by their particular group. In this case, because of the particular values we get, it doesn't really matter. It doesn't look like it matters, but in fact it does. So we go ahead, form the matrix A, and we've got our initial value here for x sub 0. And from there, we'll go ahead and compute the eigenvalues. So we get lambda 1 and lambda 2. We can do that just by taking the matrix here A and putting it into octave and asking it to find the eigenvalues for us. We can then go down and find the eigenvectors associated with each eigenvalue, making sure that we're staying careful to pair up the eigenvalue we're calling lambda 1 with u1 and lambda 2 with u2. So that gives us our eigenvalues and eigenvectors. From there, we need to come up with the appropriate linear combination of coefficients that produces the initial value. So you see we've got our x0 as 400 and 800 up here. And we've set up our eigenvectors, and we're looking for these coefficients, A, A1, and A2, that will generate the x0 output. So this is all kind of coming down to this particular formula that we've got that helps us generate generate the general term x sub k. You can see what we need. We need this A1 and A2 that we're talking about, which is, again, the linear combination of the eigenvectors here and here that will produce the initial value. So we get those. We also need the eigenvalues, lambda 1 and lambda 2, and the associated eigenvectors. So those are all the components that we need to fill in our general term x sub k before we can actually evaluate it. So again, just reviewing that, we set up our matrix A, we grab our initial value, we then go in and find the eigenvalues and eigenvectors for the matrix A that we created here. We then go and figure out what A1 and A2 are, these coefficients that represent the linear combinations. And then we can just plug all of that stuff in to this particular formula here. So we get that, in this case, x sub k is going to be 200, 1/2 to the k, and then the eigenvector that's associated with the eigenvalue of 1/2, 600, 1 to the k, and again, the eigenvalue and eigenvector need to be paired together there as well. So once you have this particular formula set up here, it's really now a matter of writing it out in the appropriate form, or essentially just evaluating the limit as k goes to infinity. So if we take the limit as k goes to infinity, we can either do it here, or we can write it out like I've done here and then take the limit. It doesn't really matter. We get the same value in the end. If we want to try and rewrite this as a single vector, it's really not too hard to do. Let me just see if I can create some space here for us. So here we would go ahead and rewrite this now as multiplying all of this into a single vector would look like minus 200, and then you would have 1/2 to the k, and that would be 200, 1/2 to the k times -1, and then 200, 1/2 times k, 1/2 to the k times 1, which would be 200, 1/2 to the k. So that would be or the first vector here. Then we need to add to that the result of combining this together into a vector, which would be 600, 1 to the k, and 600, 1 to the k. Now it's important to recognize that 1 to the k is going to be equal to 1 no matter what value the k is. So it's always 1. So really, this vector here, the second one, can be reduced to just 600 and 600. Now you can add these two together, and we get a resultant vector here that looks similar to what I've written out here. So we would have minus 200 times 1/2 to the k plus 600, and 200 1/2 to the k plus 600, like that. Now over here in the problem as I originally had it, we've got that the order has been reversed, but that's really no consequence here. So now we take the limit as k goes to infinity. When we do that, each one of these terms will go to 0 because 1/2 to the k, or 1/2 to the infinity, is going to end up going to 0. So these terms drop out and go to 0, and we're just left with the limiting value here, which is the vector 600 and 600. And what we would interpret then is that the steady state solution is that we would approach a 50-50 mix of the original 1200 that we had. Again, our initial starting value was that we had 400 Republicans and 800 Democrats. And under this particular problem, the long-term solution would be 600 Republicans, 600 Democrats.